By the end of today's lesson, you should be able to graph square root functions. We will talk about the cube root functions on Friday. This is what the square root function looks like. It looks like a parabola on its side, about half of it. But notice that there are, in this case, no negative points down here at the bottom and no negative x's over here. And that's because, remember, when we take the square root of a number, I can't take the square root of a negative number. That would be an imaginary number. And as long as there's no negative sticking in front, I'm not going to get any negatives, because when I evaluate the square root of x, I just get positive numbers. Now here we want to graph the 1/2 times the square root of x. Now for all of our square roots and cube roots, all we need to do is make a t-chart with x and y, and then come up with our x's, calculate our y's, and then graph the points. So in this case, our x's that we plug in are very specific, because since I can't use a calculator, I can only take the square root of certain numbers that I know for sure. Of course, we can take the square root of 2, it's some sort of decimal, but because we're not allowed to use calculators in this class, then we're going to have to pick numbers for x that are whole number square roots. So I know how to take the square root of 0, that's just 0. And I know how to take the square root of 1, that's 1. And I know how to take the square root of 4, that's 2, and the square root of 9, that's 3, and the square root of 16, that's 4. Now that we've come up with the x's, now we need to plug it in to come up with the y's. So I have 1/2 times the square root of 0. The square root of 0 is 0, and 0 times 1/2 is 0. And then I have 1/2 times the square root of 1. The square root of 1 is 1, and 1/2 times 1 is 1/2. Then I have the square root of 4. The square root of 4 is 2, and then 2 times 1/2 is 1. And 1/2 times the square root of 9. The square root of 9 is 3. 3 times 1/2 is 3 over 2. And then we can keep going. 16 is 1/2 times the square root of 16, which is 4, which is 2. Now we have to graph this thing. Now they're all positive numbers, so I'm going to scooch it over this way, my graph, so that I can fit as many of them as possible. So 0, 0, 1, and then 1/2, and then 2, 3, 4, and 1, and then 5, 6, 7, 8, 9, and then 1 1/2. 3 over 2 is the same as 1 1/2. And then 16 goes off my graph, so I connect the dots like this. Now the last thing we need to do is talk about domain and range. So remember, domain is all the x values that we can come up with, or that we can plug in for x that'll give us some sort of number, whether it's real, or whether it's a whole number or a fraction, decimal, it doesn't really matter. And the range is the y's. So if we look, we can get our starting points from the very first point that we have, which is 0, 0. So x and y both start at 0. And then if I look at that point right here, it goes this way on the x-axis. So if it starts at 0 and goes to the right, that's got to be greater than or equal to 0. Then if I look at the y-axis, it starts here at 0 and then it goes up. Right? This graph right here is going up eventually. So that's greater than or equal to 0 as well. Okay, now you try this y equals -3 square root of x. All right, we need a t-chart, and the only numbers I can plug in for x are 0, 1, try that again, 4, 9, and 16. Now I plug those numbers in for x, so I get -3 times the square root of 0, which is 0, and then -3 times the square root of 1, which is just 1, -3 times the square root of 4 is 2, -3 times the square root of 9 is 3, and then -3 times the square root of 16 is 4. So we get 0, 3, -6, -3, -6, -9, and -12. So now these are negatives, so let's scooch it up this way. So we have 0, 0, and then we have 1, -3, and then we have 4, -6, and then 9, -9, and then -16 goes off the graph, so it looks something like this. So for all these square root functions, you need, for me, at least 3 points. Now let's talk about the domain and range on this one. So we start again, we start at the 0, 0, and the x's are all going to the right, so that's greater than or equal to. The y's this time, though, start at 0, now they're going down this way, so that's less than or equal to 0. So just remember that when it comes to the domain, to the right is positive, to the left is negative. And then with the range, down is negative and up is positive. So this is like greater than, less than, greater than. So pause the video and try this one yourself. We want to graph y equals 1/4 and then the square root of x. So we need to make a t-chart again. And again, I get 0, 1, 4, 9, and 16. And then I plug in the numbers, so 0 will be 1/4 times 0, which is 0. 1 will be 1/4 times 1, which is 1/4. 4 is going to be 1/4 times 2 this time, and that's 1/2. 9 is 1/4 times 3, so that's 3/4. And then 16 is 1/4 times 4. And 1/4 times 4 gives you 1. So let's graph that now. Those are all positive numbers again. So we're going to scooch our graph over this way and then graph those points. I'm going to make the 1 up here. That way it'll be a little bit easier for us to graph that top part. So 0, 0, 1 and 1/4, 4 and 1/2, 5, 6, 7, 8, 9 and 3/4. And then 16 and 1 is off the graph. So our domain for this one is greater than or equal to 0 because it's going to the right. And our range this time is, range is y, is greater than or equal to 0 as well. Here we have a problem that's a little bit more difficult. So now instead of just the basic square root of x, now we have the square root of x minus 3 under the square root. So when we make our t-chart this time, we want what's underneath the square root. So this part right here, we want that to be eventually 0, 1, 4, 9, 16, because those are the numbers that we know how to take the square roots of. And we always have to start with the 0 or else we won't get the beginning of the square root function. So we have to figure out what number x has to be in order to get 0 under the square root. So if I want something minus 3 to be 0, that something has to be 3. There's no other number that it can be. And we are not considering this plus 2 at the end because that's not under the square root. So now if I want this something minus 3 to be 1, that something has to be 4. And if I want something minus 3 to be 4, that thing has to be 7. Then if I want that something minus 3 to be 9, that thing has to be 12. And then 16 has to be 19. Another way to think about it is I want that x minus 3 to be 0 because I know how to take the square root of 0. So if I add 3 to both sides, I get that x has to be 3 in that case. Same thing with 1. If I want x minus 3 to be 1, if I add 3 to both sides, then that x has to be 4, which is what I got here. So whether we set up an equation to figure it out, or whether we use some logic to figure out what the answer is, it doesn't matter which way as long as we get the correct answer. Now we plug in those numbers that we have. So negative 2 and the square root of 3 minus 3 plus 2. The square root of 3 minus 3 is 0. And negative 2 times 0 is 0 plus 2 is 2. Now we do the same thing with 4. So square root of 4 minus 3 and then plus 2. The square root of 4 minus 3 is 1. And the square root of 1 is 1. And negative 2 times 1 is negative 2. And negative 2 plus 2 is 0. Now we do the same thing with the rest of the problems. With the rest of the x's. So 7 minus 3 is 4, and the square root of 4 is 2. Negative 2 times 2 is negative 4. Negative 4 plus 2 is negative 2. 12 minus 3 is 9. The square root of 9 is 3. 3 times negative 2 is negative 6, plus 2 is negative 4. And then we would do the same thing for 19. 19 minus 3 is 16. The square root of 16 is 4. Negative 2 times 4 is negative 8, plus 2 is negative 6. Now obviously not all of those points are going to fit on the graph. Remember that we only need about 3. So I'm going to plot the first 2. So 1, 2, 3, and then up 2. And then 4, 0. 7, negative 2. And in this case, I can go all the way to 12, I think. 7, 8, 9, 10, 11, 12. And then down to negative 4. So this time our graph looks something like this. Our domain, our x this time, starts at 3, and it goes to the right, so that's greater than or equal to. Our range starts at 2, and this time it goes down, so that's less than or equal to. Okay, you try to graph this one on your own. Let's see if you came up with the correct numbers for x. So, if I want it to be 0, 1, 4, and 9, and 16, in order for the number under the square root to be 0, x has to be negative 2, because negative 2 plus 2 is 0. And then if I want that thing to be 1, then x has to be negative 1, because negative 1 plus positive 2 is 1. Then if I want that thing to be 4, x has to be 2. If I want that thing to be 9, x has to be 7. And if I want that thing to be 16, then x has to be 14. Then we plug in the numbers. Negative 2 plus 2 is 0. The square root of 0 is 0, and 0 times negative 4 is 0. Then we plug in negative 1. Negative 1 plus 2 is 1. The square root of 1 is 1, so negative 4 times 1 is negative 4. And if I plug in 2, 2 plus 2 is 4. The square root of 4 is 2. And negative 4 times 2 is negative 8. And I plug in 7, 7 plus 2 is 9, square root of 9 is 3, and negative 4 times 3 is negative 12. And then 14 plus 2 is 16, the square root of 16 is 4, and negative 4 times 4 is negative 16. Now we graph this thing. All the y's are negative, so I'm going to scooch this thing over about there. So negative 2, 0. And then negative 1, negative 4, 2, 2, 3, negative 8, 2, 3, 4, 5, 6, 7, and negative 12. So this thing looks like this. Domain for this one, the x's start at negative 2, and they go to the right. The range for this one, the y start at 0, and then it goes down. So it looks like that. Here's your homework, and this is homework you're going to need to turn in and get credit for it. So in your workbook, page 104, 1 through 6.